Hi everybody, Charlie here from Sterling. It's becoming more and more frequent that people have 48 volt leisure batteries or 48 volt ancillary batteries. They have them on board, yet they still demand a 12 volt system. They might have 12 volt house battery, 12 volt auxiliary battery, domestic battery, whatever you want to call it, and they wish to charge from the 48 volt battery to the 12 volt battery. So then naturally they're after a DC-DC charger that will take 48 volts and buck it down to a 12 volt or a 14 volt charging profile. Now, a proposal that we have is this particular model is a 30 amp solar charge controller. Seems odd to use a solar charge controller, however, the principles of the bucking mechanism of the 2-switch buck boost takes high voltage, bucks it down to a 4-stage battery charging profile at 12 volts. This will also work for a 24 volt battery as well. So you could have a 12 volt battery here or a 24 volt battery and feed 48 volts. I've actually got 51 point something volts going into it, so I'll just turn on my voltmeter and I'll demonstrate the voltage going in to the solar charge controller. So 51.7 volts across the input there. They're shared negative, so that orange cable goes to the 48 volt battery, that's the 12 volt battery, and then that's the common negative. So we had 51 volts going in, and it's bucking it down to 14.4 volts, and the current, that's actually a little battery monitor there, will tell you it's 411 watts that is coming out of that solar charge controller to charge up your 12 volt battery. Now, the caveat with this is, for as long as it's connected to a 48 volt feed, it will carry on dragging that 48 volt battery down to as low as empty if there is enough space or enough demand in the 12 volt battery to accept power. Therefore, there's no turning off mechanism. So provided it sees voltage here, it will buck that power down to the 12 volts to keep your 12 volt battery topped up. I am, however, predicting that if you've got a 48 volt system, the chances are there's high power here, there's probably a lot of storage, there's probably constant 48 volt charge going into it somewhere, or discharge, i.e. these batteries have probably got surplus energy in them to meet that demand anyway. If you don't have surplus and you need something to activate this device, then you can go down the line of an ignition fed relay, where you could, in the 12 volt line, put an ignition fed relay, or in the 48 volt line, you could put an ignition fed relay. These solar charge controllers are self-correcting. So what I mean by that is, if I was to disconnect 12 volts from it here, if I literally just unscrew 12 volts from it, it will error. It won't like that at all, just because you've disconnected power from it. So it's erroring. Error 2 just means low DC voltage. Well, yeah, because I've just disconnected the 12 volt battery. If I reconnect it, it fires back up and just carries on charging. So it resumes operation. Let's just make sure I've tightened that up nicely. There we go. It's just a bit loose in the connector. So I've reconnected the 12 volt up and it's back up charging again. So it self recorrects, turns back on again and begins charging. Likewise with the 48 volt, if I was to remove the 48 volt feed, i.e. with an isolation switch, or just by, these are lithium batteries so I can just turn it off on my phone, if I was to remove that now, all what happens is the charging stops because there's no pressure from the solar, no current flow, and the unit just sits there with the battery's voltage at 13.9 volts. And then if I reconnect solar back into it again, little spark because we're at 51 volts, and then the solar shall begin again. You see it's just recognised the solar feed there, and we should be back charging again in a moment. Let me just make sure that's nice and tight. Solar LEDs just come on, so I know something's happening, and then that display should fire up any second with the flow of current. Just wait for it. There we go. So there we go, back up 400 watts again, 30 odd amps. So you can disconnect either of those, and they both, so you can disconnect either the 48 volt with a switch or the 12 volt with a switch, and the unit will fire back up again and carry on charging. So you don't need to touch anything, there's nothing that needs resetting. There's an error code, yes, but it self-corrects once it detects. So that can be permanently connected to either your 48 volt stack, then Anderson socketed to the 12 volt battery whenever you wish to connect it back up, or just leave it permanently connected. If I was to have a system where I had a high capacity 48 volt battery and a smaller 12 volt system, the chances are I will always have surplus in my 48 volt battery. Therefore, I can leave this hardwired as is forever. I don't need to disconnect anything. I don't need to worry about the 48 volt battery draining, because the chances are I will always be charging this unit up every night, all the time. It may be hooked up to a big inverter charger that's charging up at 48 volts overnight. It might be a big solar system connected to a big off-grid system, something like that. There'll always be power in the 48 volt stack, because if you've gone 48 volt, the chances are you're in demand of power, whereas your 12 volt side is often smaller, less power consumptive. So having this on permanently is a very small, in the grand scheme of things, parasitic drain on your 48 volt battery, but it does the job nicely. And like I say, you can always introduce an ignition fed relay into either one of those positive leads to isolate the product if you wanted to switch it off. But there you go. You can set the regulator to different charge voltages. It comes with its own app. It's even got an additional 12 volt 30 amp limited feed on there as well, so you could tap off to an additional 12 volt load, for example. You could run a 350 watt inverter from directly off that load. So there's lots of flexibility there. And like I say, this can work at 24 volts as well. All right.